All right, let's do a simple linear regression with Python. And imagine that you want to buy a home. And let's say you want to buy a home in a specific neighborhood, and you're not sure how much to bid for that home. Yeah, because you might be bidding higher or you might be bidding lower based on what the market situation is. So, what if you could build a linear model that could tell you the predicted home price that you are bidding for this specific home? It will tell you what could be the sale price for this home. So if you knew the sale price that is likely for this home with this linear regression model, then you could bid appropriately. Maybe you will not bid as high. So let's create this simple interactive um, linear regression in Python. And for that, we just need these three libraries: NumPy, data science, and stat models to start with. Yeah. So NumPy is this package for computing in Python that's very helpful. Stats model is another one which helps do lots of statistical calculations. And Berkeley has open sourced this package, data science, which was originally for Data Science 8 course, and it has lots of these really good functionalities that we can use for investigating data, creating tables, and then graphically using that data. So with these three libraries, let's go ahead and import them. Yeah. If we import these three, that's all that we need for this. Yeah. And let's say you have a specific home in mind. I'm just picking one example. Let's say this was that home. Yeah. And I have the website Zillow, where it gives me some data points saying, hey, this is the home that I'm interested in, hypothetically. It has a listed price, it has how many bedrooms, it has so much data here: bathrooms, square feet, it has the year when it was built, price per square feet, how many acres there is, and you can start to get a lot of data. Here it says, oh, this is on the market for 144 days. And it also tells you how many people have viewed it and how many have saved it. So you could imagine, what if your linear model could parse out from all of this data that's available um, for this home and for all of these similar homes that were sold. What if it could tell you, hey, you should probably bid $2 million, 10% lower? Or maybe it should tell you, hey, you should bid 5% higher to have a higher chance. So that's the goal, yeah? Given a home, we should be able to predict what price we should bid at using a linear model. So that's our goal. We're going to create this Python code that does that in a very simple 10-step process. So step one, what's the step one? For us to build any model, we would have to get data that model learns on. So the first thing is for us to ask our real estate agent, hey, give me historical 10 years data of all of the home prices in Walnut Creek. And in this case, you could also tell them that, hey, I only want homes above, let's say, 2,000 square feet, and homes that have at least a few 2 bedrooms and 2 bathrooms or something like that. And they will give you this kind of a CSV data. So we need data. And I asked my agent, and he gave me 10 years of really rich data that told me for every home, how many days was it on the market, when was it sold, what was the listing price, what was the selling price, what's the HOA fee um, for the home, how many bedrooms, how many bathrooms, so on and so forth. Yeah. So we first need this CSV file, in which has, like, in this case, I have like close to 3,000 data points, real data points. Yeah. So your model will only get as good as the data that you feed in. So this is the first basic step. Once you get this data, and let's say I call it walnutcreek.csv, yeah. So you place it along the same folder as your code, and I'm going to call it linear regression code. Yeah, and I'm using Jupyter Notebook on my local machine to run this code. So yeah, let's get started. First step, I'm going to create a new cell by hitting the plus icon, and I'm going to just see if I can read the data. Yeah, I want to read the data in a table, and we have imported data science, which has these tables that we can use. So what we will do is we will read the CSV file, and we will call that file on and create a table out of it. Yeah, so we call table dot read table, and then we give it the name of the CSV file. That's our CSV file, and then we hit Control Enter, and then we get table is not defined. So this is a classical error. So what happened here is that this reference is not defined. So what we'd have to do is we'd have to first run this cell, because if we don't import this, I'm going to do Control Enter, or I could do run all cells, and then it's going to run this first, and then I'm going to get this one. So now I was able to read the data. Yeah, table.read table CSV file, simple. And let's say I'm going to store this in a variable called data, and I can also do the same, which is just print out the data. Yeah. So now we can start to see that, hey, this CSV file that was here is now parsed, and it's in a table object. So that's an important aspect, because now we can do manipulation on this. So it has parsed all of the CSV data into this data table. And what I'm not covering in this is I had to do a lot of data cleaning on this CSV file. There were lots of empty cells that I had to clean up, some dollar numbers that I had to put it in simple numbers, and lots of data cleaning needs to happen to this CSV file before you can actually use it. Or you can do this cleaning in code, but I just chose to do it here. Yeah. So now we are sure that we can read this table, and what we need to do now is look at from all of these data points that we have, what is it that this data is telling us. So we can do some sort of analysis, and say, hey, let's look at like the mean, the median, and like the standard deviation for all of the data that we have. Yeah, for, let's say specifically we want to do that for the sell price. Yeah. So what we do is we call median, and then we call data.column, and then we have sell price right there, and then we just hit enter. So we get like the median price. Look at that. We got the median price for all of the data that our realtor gave us in the CSV file, and similarly we can do mean, and that's how we will get the mean. Yeah. What I also want to do is I want to print all of them. Yeah, to see that one data at a time. Yeah, we're able to see the median, and latest we saw the mean. But what if we want to see everything? If we want to see everything, we can just display all values by overriding this variable interactive shell AST node interactivity to be all. If I do that, all of this table. Yeah, so the data table is printed, the median is printed, and the mean is also printed. So everything got printed. Yeah, by just overriding this property. So now we have the median, we have the mean, and we can also do standard deviation. Yeah. So we get to know like what's happening here for our data. Yeah. So median, mean, standard deviation. So we get to know, okay, 1.3 million is the median, 1.4 million is the mean, and standard deviation about 50,000, no, $500,000, $490,000. Yeah, something like that. So this is how we explore the data. Yeah, we look at this data and then we start to explore it. Once we get an idea here, the next step for us would be to say, hey, I want to now understand, um, is there any correlation between some of these cells that we have? Yeah, all of these columns. Is there a correlation between having an HOA fee and lower price? That makes sense. Yeah, if you have to pay a HOA fee, maybe you won't be able to sell it at a high price. Maybe there's a higher square feet, could have a higher price. Newer homes can have higher price. So we start to look at our data and say, hey, let's try to see if we can find correlation, between variables that are related to sell price, because that's what we're really interested in. Yeah, because given a home, we are trying to find out what will drive this price ultimately, what will drive this selling price. And so what we can start to do is look at relationship, and we can do that using correlation. Yeah, so what we do is, let's say we have data. We want to look at, let's say first we want to look at square feet, yeah, because that's the most obvious one. Higher the square feet, higher the price, yeah, is what we assume. So the CSV file now is in the table format, so we can do data dot, and if we do data dot column, and then we say, hey, I just give me the year built, yeah, because that's this one here, year built, and that just prints out all of the years. Yeah, so we are able to print out all of the years, and now we want to find out correlationship between that and the second column, sell price. I think it's sell price, yeah. So let's see if we print that, we're able to get both of these. So let's find out correlationship between them. So we can do that by using this function, correlation coefficient, and then we can give it the first array and then the second array. Yeah, and then this one here, if we print this out, that will be our correlation 31. Yeah, and we can similarly find out the correlation squared, so that'll be like 9%. So in a sense, the year built only is having 9% less variation compared to variation around the mean. So it has less variation just by 9%, explaining better than mean by, let's say, 9%. Yeah. So we start to look at this and say, hey, okay, I found out the correlation coefficient R and R squared. In this case, we're looking at R squared because we squared it. But we can do the same for other variables. Let's say we want to look at how many beds there are, how many bedrooms, yeah. And I'm going to take this out for now. So if we did that, oh, it's 4%. Yeah, so let's just print a bunch of these and try to see like what is the correlationship between year built, 9%, and let's say square feet. Yeah, bigger the homes, so square feet. We start to see, oh, square feet is like the highest. Beds is 4%, lower variation. 9%, slightly better. Years actually slightly better. Square feet, much better. Yeah. So like that, we can start to look at correlationship between each of these items. When we do that, we can find out, okay, we definitely need square feet, but we are also, for every home, look, we're also given this price. This is the listed price. So there's no reason for our model to not know this. Yeah, we know that the seller has the price, and that's also given to us, listing price. So let's try to find out, like, hey, can we do better than 36% lower variation? What if we could do like 50, 60, 80, 90%? Yeah. So let's try to see what happens if we look at listing price. So in this, we're just exploring, looking at the data and finding out what's going on, because then we can actually, oh, look at that, 93%. In a sense, the price that we see here, the listing price that someone is listing at, is a really good indicator. Yeah. And so now all of a sudden we can realize, oh, these are all the variables that are related to sell price, and we can also know the goodness of fit R squared, which is what we're looking at. Say, hey, 93%, really nice. Yeah. So we can start to do more and more analysis here. Um, but in a sense, what we have done is we found out variables that are interesting, that we should tell our model to train on, the linear model. Yeah, that's our ultimate goal. And when we do that, we can start to even not just look at these numbers, but we can also do some data visualization. Yeah, when we're exploring this data, we can say, hey, I want to um, now build a model, just build a simple linear regression model. So I'm just going to go here. I'm going to keep all of this history for now. It gives us, we were able to see the data. We were able to find out which variables are related. And now let's try to find out a basic linear model and see what is its R squared. Yeah. So let's say I build a model, and I build an ordinary least squared model. And I'm saying, hey, I want to predict sale price based on, let's say, all of these variables. But let's start with a simple linear regression model. In the simple linear regression model, we say, hey, I just want to use square feet for now, because that's probably like the closest um, that we have. So hey, based on square feet, predict sale price. Yeah, and then use that from use the data points that I give you and do a fit. So you do OLS sale price, predict sale price based on square feet that we have, and then you give it the data, and then that's it. And when you do that, we can have model dot R squared that we can print out. So OLS, okay, so it says OLS is not defined, but we have included all the libraries that it has. But in a sense, the mistake here is it's small OLS, not capital OLS. Yeah. So now we see, oh, this model square feet has 36% less variation than a simple model around the mean. This is good. This is good. Yeah? You're able to build a simple linear regression model. Yeah. Based on square feet, given any square feet, we can find out the price of the home that it actually sell at. And so let's try to draw, like, what does this fit actually look like? So we can use a scatter plot, and let's select some data points. In this case, we have square feet as a column that we need, and then we need sell price. Yeah, those are the two. Based on square feet, what are the so what is the sell price going to be? And we want to do a scatter plot, and we want x-axis to be square feet. Yeah, and then I also want a line, the line fit. So I'm going to say line fit equals true. Okay, so if I want to plot this graph, what I will do is I will use this matplotlib inline function, which will actually plot this graph. And then if I do this, then we get the line fit as well. You see this line? Yeah. So it's basically we have this linear model that's able to, given any square feet, predict the price. Yeah. So we are able to build a linear model, and we can do the same. We can change this from square feet to copy this code and then build another model. Instead of that, we can use, let's say, year built. And so here, let's say year built, I see if the home is old, then maybe cheaper. So let's run that. Okay, we got an error. Spelling mistakes are not allowed. Year built. Yeah. So let's run it again. Okay, there you go. So year built. Look at that, right? Um, but it has a much lower good fit. 9 enters. Yeah. So we did that for year built. We did that for square feet. So similarly, we can start to experiment various variables. Yeah. And as we saw, the listing price is actually a much better indicator. So what if we did that? Yeah. Copy this and say, hey, I want to build a model on the listed listing price. Yeah. So I'm going to copy that listing price, copy that. There you go. If we run this, we will get 3 different models with 3 different R squared, and we get square feet predicting sale price, year build predicting sale price, and look at that, listing price predicting sale price. So much more better indicator. So we're able to build 3 different linear models with just a few lines of code by first exploring the data and then using this OLS ordinary squared model to build and predict dependent variable sell price based on these 3 different independent variables. Yeah. So that's as simple as that. And if we want to now use this model to make a prediction, we can do that. Let's use the model to make predictions. Yeah. So let's say we want to predict this home price. Yeah, we want to bid on this home. That was, remember, our goal. We want to bid on this home and we want to predict for this home what would be the price that I should bid, and most likely the sell price is going to be closer to that. So then what I do is I'm going to look at model.params because that's the last model that we ran, so it's going to have just this variable. Yeah. And in a sense, it's telling you that listing price and the listing price coefficient is 1.005 and the accept is 35029. Yeah. So if you want to predict the price of this new home, yeah, predicted price of the new home would be at, and we know the listed price is equal to 2.2 million. So we're going to just add that. That's given. Once that's given, we know model.params 0, which is this intercept, plus the listing price that we are given, which is this one, times the coefficient, which is model.params 1. Yeah. So that's going to be the new home price. Let's see if this runs. All right, error again. Let's look at that. Okay, can't do spelling mistakes. Yeah, params. Okay. go. Um, Now we want to print this. Yeah, let's see if we can predicted price of this home. Just call it predicted price. Yeah, go. 2.2 million home is saying the predicted sale price is going to be $2.24 million. So you want to go a little higher based on this simple model that we built. So now we're able to make some predictions, and we can do that for as many homes as we want. We can keep predicting as many that we want. So not just this home, we can do more. But can we make our model a little bit better? Yeah, that's the key. And can we check if we can use our model that we predicted one home? Can we predict all the homes that we have in the data points that we are given by a realtor? Of course, we can do that. So let's do that. Yeah. So what we'll do is we will do data dot with column. We'll add a new column called predicted price. Yeah. So what we do here is we say, hey, I want to add a predicted price. Say I call it, and I'm gonna populate this by calling model dot predict. Yeah, because that's what will give us the price for all of this. And then if we print this out, look, we are able to get a price prediction for every home, because this model or predict will go through every row and populate this new column price predicted. And we can now see what is the sale price and what does the model say would be the sale price. We can do the plot again. We can say, hey, let's see what does that plot look like for the prediction. So we do data select whichever columns we want. In this case, we want listing price and sell price. And price predicted, which is what we just created. And then do a scatter plot on have the listing price. There you go. So if we scroll down, okay, we have an error. Price predicted. Okay, we didn't assign this. Yeah. So we need to, basically this column doesn't exist, but we need to save it. Yeah. So I run it again. All right, here we go. So if we save it and then we ran it, then we can see, hey, what we predict is in yellow, and what we see here is sell price, actual sell price. And you can see that it's a really good fit in that sense. Yeah. So we're able to predict home prices for all these 3,000 data points, add a new column for all the price prediction. And can we, with this, use to predict? Yes, absolutely. We just were able to find out for this home, for various parameters, what would be the predicted price. But remember, our model is very simple still. It is a simple linear model. Yeah, it only uses one variable, in this case listing price. Can we do better? Can we start to say, hey, because this home, the value of this home should change, prediction should change, let's say based on how many days no one really buys it. The more people don't buy it because it stays on the market, ideally price should go down. Yeah, because then there'll be price cuts. So that's our intuition, but let's check if that's actually the case. And so let's build a multiple linear model with more than one independent variable, and see if we can, instead of just using the listing price, can we also use things like how many days on the market is this house open. So what we do here is we can we can use a variable that's given to us. It's called DOM, days on market, like that. So this number here, 428, is basically telling us this many days this home was on market. But in this case, it's 144. So this home is on market for a much longer period of time. So let's build a multiple linear regression model that actually looks at this categorical variable. In this sense, we have days on market. It could be a number, yeah, of number of days. And if we can incorporate that, and instead of just having a simple linear model, if we have a multiple linear model, multiple variable incorporated, then that would be great. Yeah. So let's do that. Yeah. So to do that, what we will do is we will build the model and say, hey, model, new model equal to OLS, and I want to predict the sale price based on listing price, plus I want to do it based on like how many days on market this home was on. Yeah, I'm going to give it my data and say, hey, do a fit, and then do model R squared, 95%. Great. Yeah, 95.6. Yeah. Initially it was the R squared before, 93.8. Okay, so we just improved our R squared by adding how many days on market this home was available. So that intuition also holds. So now we can have a better price. We can bid. Remember, this model initially told us you should bid how much for this 2.2 million home. You should bid 2.24 million. Yeah, but now we're going to make our model better. Say, hey, I want you to factor in the days on market from all of the data that you have and get better. Yeah. And we just saw that the model R squared got better. So now let's make it to predict our, let's just use what we have here. Yeah. We remember we did this predicted price. So what we can do is say, hey, model dot params. If we run this, we will start to see that, hey, we have this categorical variable that gives negative impact. Initially, our intercept was a positive intercept. Now we have intercept negative, and we also have this negative weight. If it's lower the number of days on the market, it has a positive impact. Higher the number of days, it has a negative impact. And the listing price also went down a little bit. You see, it was 1.05 before the coefficient, and now it's 1.005, and now it's 1.01. Actually, up, yeah, one day up. So we can do the same, yeah. We can instead of doing this, because we had the first parameter, which was the intercept, and then the second parameter was the coefficient for the listing price. What we'll do is we will say, hey, predict the price slightly differently. I'm going to keep it here because we are having a categorical variable. We can say model dot predict, yeah, and then we're going to give it table with columns because it needs all of these inputs now. Yeah. So listing price, we are given the listing price. In this case, what was our listing price? 2.2 million. Yeah. And then we are given the days on market. How many days on market? 144. So I'm going to fit that in. So I'm going to say DOM 144. Yeah. So if I did that, yeah, I'm going to say do the same mod predicted price, and I'm going to copy that here, same variable, and then if I'm going to print that, let's see if that works. Yeah, predicted price Okay, invalid syntax. Predicted price equals model dot predict table with columns. I think I might have missed a bracket. There you go. Let's see if that works. Yes, it does. Great. Okay, so look at that. Now we're able to get the new predicted price of $2.1 million, lower than 2.19. Not that low, but it's still lower than what we had earlier. Yeah, 2.24. So now all of a sudden our model just saved us money because it realized, oh, by adding days on market, our model got better, and we're able to now know that we should bid lower for this home, not higher, or the price cut is coming. Yeah. So this is a simple way in which we can keep improving our model. We started with listing price because we saw our square was much higher, backed by looking at just correlation data that we saw earlier. We added another variable, and like that we keep adding any more variables. You can just keep adding, let's say, square feet. Yeah, and let's say you have a 3,000 square feet. Then you can add square feet here to train the model. Let's see if that runs. There you go, it does. So if you factor in square feet as well, and also the model telling you to factor in this price. But let's see how many square feet does it have? It's 3,387. So then I'm gonna change that. 3,387. 19. That's actually the negative impact. Yeah. So look at that. Square feet, negative impact. And so basically you can keep adding as many variables and you start to see your model R squared. And so with this, we are able to perform a simple linear regression, multiple linear regression to build a model that tells us how much we should bid. And in just a few lines, yeah, maybe 15, 20 lines, we're able to build a model that is going through thousands of data points and telling us the information as to what should we be bidding. So like this, we can use machine learning models for so many use cases, and this was just the start. Thanks. So to quickly recap, what we learned is by importing basic libraries, NumPy, data science, stat models, we are able to, for any given home, build a linear model. And for that, what we needed first is the CSV file or some data file that our model can train on. And we got this data file. In my case, I got it from a realtor. I had to do lots of data cleaning. In this case, these zeros didn't exist before. So for HOA fees, they were just empty. So about 3,000 actual data points. Then I was able to do some exploration and did some data analysis, median, mean, standard deviation. We were able to find, hey, which of these columns actually have relationship with the sell price, and what would help us is correlation, and we are able to plot some of those data relationship with square feet and with sell price and year built with sell price. Once we found out that, hey, they still are not that high in explanation, at best we were able to get 36%, then we started thinking about um, listing price, and that's when we found a 93% R squared, which was a really good fit. And once we found those variables, which is, in exploration, you try to find these variables that actually are helpful in building the prediction. When we did that, we can then actually use the model parameters to actually, for any price, we look at the $2.2 million home, but we can put in any price and then be able to predict with a senior linear input what would be the price of this new home. Similarly, you can do that for all of the data points. So we added a new model, price predicted, which will be this column at the very end. For every row, we were able to use our model to predict. And we then made our model even better with adding multiple independent variables, not just the listing price, but also square feet and beds and bath, right? And so we saw that the R squared further improved, and then we're able to predict again, saying, hey, let's go predict again, like what is the price is now. And we're able to see the prediction versus actual sale price based on square feet, beds, bath, and finally we said, hey, can we do better? And then we incorporated the days on market, the DOM categorical variable, and we said, hey, yes, we could do better by incorporating the days on market. And then we saw that, hey, higher the days on market the home is available, the lower the price. And so we are able to then factor in, say, hey, given days on market of 1, the price is much higher, 1.8 in this case, specific example. But if days on market is higher, we start to see that the price is lower and things like that. Yeah, so we can put in any number here for any home that we're interested in. We use this one, but you could put in any one that you are interested in and use this model to predict prices and then bid appropriately. In this case, the model just saved us close to $100,000. Yeah. All right. Thanks.